All right, everybody. Welcome to the EMAM PLC to PLC Communications live stream. Just doing a quick audio check here. Looks like everything's registering okay. I think everybody's slowly coming online here. So we'll wait a couple more minutes here and we'll get started on produced and consumed for
All
PLC
right, everybody.
Communications. Welcome to the EMAM PLC to PLC Communications live stream. All right, slight technical difficulty, but I got that sorted out now. There we go. All right. So I do have the chat up and running. So if you are in the chat on YouTube, check it out. Send me some messages if you need any clarification or anything kind of fixed up. This is going to be our first attempt at doing a live stream and setting things up. So hopefully everything works out the way I want it to. I think this one will actually be a little bit quick. Produce and consume tags are relatively straightforward, not too difficult to manage. So hopefully everybody um, catches on and kind of understands what we're trying to do and how that works. Um, and then hopefully there'll be some time afterwards. I'll answer some questions if anybody has any. And yeah, we'll go from there. Wait a couple more minutes. I think some people are straggling in here. I sent the invite out a little bit late, but I think most people should be getting online here shortly. So one of the things here you'll see we've got our my background here for the computer. Also, we will be showcasing off the hardware setup. I can do a quick flip over to that so everybody can see what the hardware looks like that we'll be using. So here's our hardware. So I have two PLCs, two Allen Bradley PLCs that we'll be using, both out of the 5380 family. The one on the left is slightly different, although it looks very much the same. One on the left is what we call a L306 ERM. Now, in the naming architecture for the 5380s, the L306 ERM, when we add an M to the end of it, it allows us to add motion control to it. So this Compact Logix PLC actually has the ability to do some very simple, but very handy motion controller work. So we can do like servo applications. We can put in the motion instructions, and that's all stuff for another time. We'll cover that in maybe a future live stream or in another conversation of some sort. The one on the right is just a standard L306 ER. These are both out of the newer family of PLCs, so these are the ones that I use um, in my personal business, as well as to do testing and setting up of for the EMAM labs themselves. Now, what you'll find here is that we also have a network switch in the middle between them. So that's just a standard unmanaged network switch, 5 port. It takes 24 volts DC to run that. Typically, we need one of those anytime we're connecting up communications protocols together because the Ethernet communications does require the transmit and receive wires to be flipped. So you can either use a hub like we have here, or you can use a crossover cable. Now, the crossover cable basically is a special cable that already has the wires inverted inside. From class, you'll remember that when we talked about RS-232 and serial communications, where the receive and transmit wires need to be flipped in order to be able to create that communication protocol. All right, so back to the main screen here. Kind of let the stragglers roll in about a couple minutes. I will get started to setting up the programs, walking through produced and consumed tags, and we'll go from there. So again, if anybody has any questions, feel free to jump into the chat. Let me know. I'll do the best I can to keep up with what's going on in the chat and answer any questions going on in there as well. For any of the students that are paying attention, you guys can send me an email to let me know if you have any questions as well. So for this presentation, we will be using Studio 5000. I have version 30. Both my PLCs are firmware revved up to version 30. So they're all set up for that right now. Um, if you're ever interested in figuring out how to flash firmware on a PLC, please let me know. Add it to the comments, and I can do a live stream on how to actually do a out of the box firmware update on a PLC. All right, so right off the bat, the first thing we're going to have to do is actually open up Studio 5000. So Studio 5000 is our basic design software that we've been using for most of our PLC labs. For right now, what we can do is we'll make a new project. Now, we talked about the controller hardware a little bit earlier. We've got two PLCs. We've got the L306ER and the L306ERM. So the first one I'm going to set up is the ERM because it is on the left, and I like to keep things in order. So I'm going to just label this comms test 1. Right, so comms test 1 is just the way for me to label this program. Obviously, whatever your program is that you'd be using or making, you'll want to label it accordingly. You got to make sure that you're following the proper naming procedures. So you'll see if I don't put a number at the end there and I try to leave it with a dash, you'll see that the box turns red. The red box obviously means that that name's not acceptable. If I put the 1 in there, that's good. You know, the box turns back blue. If I try to start it with a 1, you'll see that it doesn't like that as well. We can't put numbers in the beginning of our naming convention either, so you want to make sure that you're keeping that naming convention proper for any of the PLCs you use. You can't obviously put a space in there either. A space will automatically be put in as an underscore because there cannot be a space in the name. So the only way that you would be able to get a space into that box is if you copied and paste from another area. So once you have the name in there and you make sure you've got your processor selected to what you want, you've got your location where you want to save it. I'm just going to save it in my OneDrive documents to keep things nice and easy. You hit next. The revisions that you see up here at the top is very important, right? So I only have revision 30 installed. Revision 30 is what we're using. It doesn't really matter what you use. You just want to make sure that you use the same version of software that you use on your computer as what you have inside the PLCs themselves. Security and protection, I'm not going to worry about that. There are ways to put passwords and security and authorizations and all that stuff on there, but that's for another time. And then from there, you're just going to hit finish. Now, when you hit finish, what you're going to see is Studio 5000 is going to come up. It's going to start to build your base program for you. So your Studio 5000 base program is slowly going to start to build up. And it's going to give us, we'll move that off to the side here, our first window. We'll see it here. We got our controllers comms test 1. And we've got an entire program set up with our PLC at the bottom with the L306ERM being the processor that we have. So now that we have that one done, we have to do this all over again. We need one for the other PLC, which is an L306ER. So here we are going to make comms test number 2. And comms test number 2 will be for our L306ER PLC. We're going to hit next. Make sure again that our revision 30 is set. We've got no protections, no securities. We don't need any of that stuff, so we're going to create that program as well. Studio 5000 will go through its little process here to try to get everything all set up. And then we'll just verify that the right processor and the right processor name all got put in there. This is one of the problems that you have with multi-monitors. Things like to move themselves around. Okay, so now we've got 2 programs set up. We've got our comms test number 1 and our comms test number 2. Now, a couple interesting things you can see up at the top here. We've actually got the actual name of the processor as well as the processor type and the processor revision. all at the top of these screens. So that's pretty handy for us to be able to keep things kind of organized. So you understand what your processor is. So if you're running two programs like I am, you'll be able to kind of keep things a little bit separated. I'm going to put these into some tiled windows here just so that we can get them all set up so you guys can kind of see. Now, what we're going to do is I'm going to flip over to the hardware for a quick second. I want you to see how the communications are set up, and we'll talk a little bit about the physical setup before we proceed with setting up the actual software itself. Okay, so I'm going to shut off my face there, and we'll talk a little bit about the PLCs themselves. So over on our PLCs, you can see that we've got a bunch of different cables set up. The way I'm setting this up is I'm using the USB cables here and here on both the PLCs to communicate to my PLC or to my PC. Having a PLC communication over USB is a lot easier, simpler setup. I don't have to worry about IP addresses on my computer versus IP addresses of the devices, especially when we're doing live streams like this. I don't have to try to chase down IP addresses yet keep my computer on the internet. So what I try to do is use the USB cables to do all my communications for that. Next up, you'll see that we have blue Ethernet cables. So these Ethernet cables are communicating and set up between the hubs themselves. You'll notice there's not a lot of lights flashing right now. We haven't done any configurations on our PLCs. So our PLCs aren't really set up to do any comms, and that's why you don't see any of our lights over here on our actual switch set up and flashing right now to show us that there's communication. On these PLCs, you'll see all the lights up here. These are our status lights on the PLCs. You'll also see they have a little LED type display that scrolls across. I currently don't have any I/O cards set up, so I'm not worried about I/O cards at this moment. I'm simply going to show you how to communicate your PLCs between each other, how you layer in the I/O and how you take this into the ladder logic and create a program. That's completely up to you. You're very flexible in how you do that. But once you get this basic architecture of communication set up, it's very simple to see how things can work back and forth. So that's our basic structure. You can see I've got my power cables and everything set up over there as well. But that's the basic hardware structure that we have going on with our system. So I'm going to go back to my main screen here. And we will talk a little bit more about how we're going to set up these two different programs that you see here. So you see here I got comms test number 1 on the left, comms test number 2 on the right. So the first thing that we need to do whenever we're setting up communications on a PLC is actually start setting up our Ethernet IP addresses. Now you should know, from class, that IP addresses are your addresses that you use for communicating between any devices. There's 2 different methods that we can have for communicating on Ethernet. We can use the manually configured IP addresses or the automatic DHCP IP addresses. In order to use the DHCP, you have to have a DHCP server, something that's going to tell a device what its IP address is. In this particular case, we don't have a DHCP server, so we have to manually configure our IP settings. These particular PLCs actually have 2 Ethernet ports on them. So you can see here we have A1 and A2. Those are actually 2 completely separate IP ports, and they have some pretty cool features and functions. Right now they're set to A1, A2 dual IP, so each one of them can have their own IP address. If we change the IP mode, we could actually have them as linear or DLR. Linear being that we can just pass them through, and DLR means device level ring. We are able to actually have our PLCs set up so that we can make them part of that ring architecture that we can have in Ethernet and Ethernet communications. So here you'll see we're in the controller properties. All I did was go to right click and go to properties. Properties brings up the general file. You look across here, we have all kinds of different information along the controller properties. What we're concerned about for today mostly is the Internet Protocol. Internet Protocol is where we configure all of our values. Now, one of the interesting things here is you'll see that we can't actually configure anything. Now, this seems to be counterintuitive because we're trying to set up our PLC. We want to be able to put all of our information in there. Now, the reason you can't set up anything is because we're actually not online with the PLC. So we have to actually go online with this PLC. So hopefully you remember how to do that. We go to Who Active. We're going to go to the USB. Now we have both of our PLCs set up on our USB. Currently we are going to be looking for the L306ERM. And the L306ERM, we'll have to just do an auto browse and make sure it shows up. Sometimes it takes a little bit longer to start communicating. We've got a bad Ethernet cable. So once we get the actual PLCs to communicate, which of course is going to cause me problems. Let's see here. All right, well, that's no fun. So what we'll do is we'll just quickly flip over to the L306ER, and we'll go online with that one. So here again, we're going to go to Who Active. This one we do definitely know communicates. There's the L306ER. So we're going to take comms test 2 and download that to our PLC. So from that PLC, we're going to hit the download button. We will then send out the information. So as we're going through the download functions and the download procedures, we'll talk a little bit more about how the devices themselves are going to actually communicate back and forth. So today we're going to focus on produced and consumed tags, because produced and consumed tags are what we primarily use in Ethernet communications. There are other methods that we can use to communicate back and forth, but produced and consumed is really the primary, the ideal way, especially in the newer versions of PLCs, to communicate back and forth. Once it's done downloading, we're going to hit the change controller back to remote or to run mode. You'll see here at the top that now we've turned into run mode. Now if we right click on Ethernet and go to properties, you can see that we are able to actually set up our Ethernet communications, which is much better for us now. So the Ethernet communications, we have to come up with some IP addresses. Now 9 times out of 10, your company or your facility is already going to have a standard set of IP addresses or specific things that they would like you to use as far as addresses are concerned. So you wouldn't really have to make up your own IP addresses. Now for what we're going to be doing, you definitely need to make up your own IP addresses. You need to, come up with some kind of architecture, some kind of standard for that. And so you want to make sure that you come up with something that's going to work for not only you, but also for your communication setup. So that's really important. So for me, I'm going to use 192.168.1. Now you may ask why. Why am I using that number? Where did that number come from? Well, the advantage to that number is that it's what we call a private network address. So a private network address is something that's not really used on the internet. It's not really used widely for other devices or other communication protocols, but it's something that we can use to help us keep locally our IP addresses away from things like servers or other devices that may cause us problems. So using a 192.168.1 address keeps that on kind of like a local private network address. We have to make sure that these first 3 octets are the same on both PLCs, because if they're not the same, those 192.168.1, then we're going to run into some issues where they wouldn't be able to communicate. This last number is the number that cannot be the same. So if that last number is the same for any reason, you're going to have issues with communications. You're going to have what we call collisions on the Ethernet side. So we don't want to have that set up. The other thing you have to set up is a subnet mask. The subnet mask basically means that we don't have our PLC going out onto our network trying to search through all of the addresses and every combination for all four of those octets. We basically mask out the first three, and we're only searching on the last octet in order to find another PLC. So that's how we set our IP addresses on that. So now what we're going to do is we're going to try setting up or try downloading to our other PLC, which I'm hoping shows up now. There it is. And we're going to download our comms test 1 to our E3RM. And once we go through the whole compiling, the routine, it's going to actually download that to the PLC itself. And once it's downloaded, then we can actually make sure that we've set up our IP addresses. So we're going to change this back to remote run. We're going to go to properties, right click on A1 Ethernet, go to properties, and we're going to look at our internet protocol. So now you can see we have 192.168.1.1, 192.168.1.2. So in theory, in basic networking theory, we should have no problem having these two PLCs talking to each other because they are on the same subnet, right? 192.168.1, and they have different IP addresses at the end, 1 and number 2. So in that case, we're in good shape right now. So we're actually able to have these two PLCs go through and talk to each other. So we're going to hit OK on both of those. The next step is to actually make some tags that we want to communicate back and forth to each other. So what we're going to do is we're going to right click on controller tags and we're going to go to new tag. So we will use comms test number 1, the L306ERM, to actually be the producer of the tag. So we're going to call this producer, and we'll just call it producer 1 so that we can have some variations of that. Now you could put a description in here. You could call producer whatever you wanted to. These names are arbitrary, but what is important is the data type. The data type that you're going to be using to communicate back and forth between the two PLCs has to be the same. You have to make sure they match. And specifically on a produced and consumed tag, the data type cannot be a Boolean bit. You can't have an individual bit. It has to be a word or a group of bits or a UDT or some way to actually communicate back and forth. Now, one thing you're going to notice, I'm going to click on type here, but the type is only going to give me base and alias. So I can't actually make a produced and consumed type tag yet. And the reason for that is we're not allowed to actually make produced and consumed tags online. You have to be offline to do that. So you'll see there's lots of jumping through hoops here in order to make these setups work for you. You know, we had to be online in order to set our IP address, but we have to be offline in order to set our produced and consumed tags. So what we're going to do is we're just going to make it a base tag for now, and we're going to call it producer 1. And on this side, we're going to make a new tag, and we're going to call this consumer 1. Again, you'll see it. I can't make any changes to base or alias. I can't pick produced and consumed tags. I am going to keep it as a dint type. The scope is going to be at the PLC level, at the controller level. So we're going to leave that up. An external address will be read and write. So we're going to make both of those tags and create those. Now, if we look into each of our controller tags, we should see that there's producer 1 and consumer 1. So at this point now, we have to actually go offline. So I'm going to take both of our PLCs offline. And once we do that, when we right click on the producer tag and we go to edit producer properties, right? So we're going to edit the actual properties of that tag. You'll see that under type, we can now actually select base, alias, produced, and consumed. For us, we want to actually set up this producer tag as a produced tag. We're going to check the connections to make sure that everything's under here is good. Now, some of the interesting things that you can do with produced type tags is actually set the maximum number of people or PLCs or devices that can consume that tag. So that's kind of advantageous for us, right? Where we can actually set up the number of consumers so that maybe 1 or 2 PLCs can consume this tag, but we don't have all of the PLCs in the entire plant pulling all that information. You can set your status bits and the data types of what we're looking at. We could actually see if the status is included in the connection status if we wanted to. All those things can be set up inside the producer tags. Once we hit OK, we just verify that everything else is OK. We're going to hit apply, and then we're going to hit OK. Now we have to do the same thing on the consumer side. So the consumer side, we're going to come over here. We're going to actually edit the properties. We're going to change this over to a consumed tag. Now, once we hit connection, we're going to notice that there's nothing in here for a producer. We don't have any selections to pick from a PLC. Now, the reason we don't have any connections or any producers in here at all is because we haven't configured any of our producers on our Ethernet I/O configuration. So since we can't actually tell this consumer where to get the information from, we have to set up that communication over here. Now, in order to do that, we are basically going to right click on our Ethernet and we're going to go to new module. So at this point now, we have to add a new module to our I/O configuration so that our consumer tag knows where to get that information from. Now you'll see there's tons of devices in here, all kinds of things. So it really helps for you to understand the part numbers, what you're looking for, what you're looking at. And you can type them in to speed up that search. So for us, we're going to look for a 5380 PLC, right? We know that that's the type of PLC we're using. And we can see here that all the catalog numbers start to show up. So since we're over here on the 5069 L306ER, we know that we actually have to pull the information from the L306ERM. So we have to make sure that when we select the catalog number, that we pick the L306ERM and we hit create. Now you're going to see the new module configuration screen. Now the new module configuration screen has a ton of information on it, and some of it's pretty critical and some of it's not that critical. One of the things we have to do, we have to give it a name. So in this particular case, we might as well just call this comms test 1 because that's what our PLC name is over here, right? You'll see we have comms test 1 on this side. So there's no reason why we shouldn't call this comms test 1. The next thing you're going to see on the right-hand side is the Ethernet address. So here's where we can type in the Ethernet address. You'll notice that the private network already exists. So we could just click on that and put in the address of the PLC. We know we set this to a 1, right? So if we go over here and we look at the properties, well, we're offline now, that would have said whatever this IP address says here, 192.168.1.1, would be what we want to set this to so that it communicates to it. The last thing that I'm going to show you that's critical, and then the rest of the stuff we'll talk through in a second, is this revision number. So this revision number has to match the type of PLC that you're looking at. So in our particular case, we hit change, and we're going to change this revision number to revision 30. Without that being revision 30, you may end up having some communication issues between that PLC and your PLC. So you'll see here we also have the electronic keying. Now, one of the things that I want to talk to you about is electronic keying is very important if you have a device that needs to talk back and forth to its device, right? So this year we're going to disable keying because we don't need it to have any special keys or special transfers back and forth. In subsequent live streams, you'll see that we actually have keys that are required, things that are very specific, and we want that to match exactly with a special key in order to be able to communicate. So here we're going to leave it as disabled because we know that's the only thing, and then connection type is none at this point. Once you do that, it's going to say, are you going to want, it's going to change it because we've changed this revision. It's going to change all the information here. Are you sure you want to do that? We're going to hit yes. Now we end up back here. It looks all the same except for our revision number now matches what our PLC is. Now you may be wondering what's after that 30, right? So 30.001, what we call the numbers on the left-hand side of the dot is our major revisions. And the numbers on the right-hand side of the dot is our minor revisions. In the PLC world, the major revisions are key. You have to make sure your major revision always matches. The minor revisions aren't as important. Most of the time, what that does is just clean up some of the issues, clean up some of the communications, clean up some of the fault and garbage that happens on there. So you don't have to really worry about that so much. Once you've got your IP addresses set up, you can go over and check your connections. We could inhibit the module when we start up. Inhibit the module means that it doesn't work, it doesn't communicate at all. We could turn on a major fault if the connection fails. So if this were a safety network or something that was absolutely critical to the operation of the system, we would actually set that up so that it would major fault the PLC. We don't want the PLC to actually run if this fault or if this communication line breaks down. Module information, if you're online, you can actually see the identification numbers, the product code, the product type. If there's any faults, you can see a bunch of that information here. The internet protocols, you'll be able to see the addresses set on here if you wanted to. Port configurations, how many ports does it have? What are the communication setups on there? The actual network. Right now we're just creating that module. And if you needed to time sync the modules together, you could do that from there as well. So at this point, we're going to hit OK. And we're going to create that module. So now what you're going to see is underneath our Ethernet, we now have the L306 ERM, Comms Test 1. Now it's interesting because we are on Comms Test 2, so Comms Test 1 is actually talking about this guy over here. So now that we've created that module, that is available to our configurations in the consumer tags itself. So if we actually go to Edit Consumer 1 Properties, we change this to consumed, and we change the connection. Now we can see that there is something in producer, right? So now we can actually see what that comms setup did for us on the Ethernet side over here. We can actually see that in the producer tags. Now the remote data is the actual tag name we're interested in, right? So for us right now, we're going to be looking over here. We actually want producer_1, right? Producer_1. And it's very important that that name or instance ID matches exactly what you're trying to pull information from. Without that, you'll have some issues. You will have bad communications between the two. Now the RPI is the requested packet information, or interval. So that's how fast and how often do we want to pull for more information. So in our case, 20 milliseconds is fine. You may find that if you have a lot of things communicating that you want to extend the RPI, right, so that there's not as much traffic on the network. But that's getting a lot more into some more in-depth information on Ethernet architectures and stuff like that. We can look here at the status. You can actually see if it's connected, connection status is included, if it's connected to the producer, is the producer in run mode, and the data type that we're looking at. Again, we're looking at DINT, right? That's the only choice that we have because the data types that we're going to be trying to transfer back and forth are the DINT data types. So we will hit OK on that. Now that we've got this all set up, we know it's consumed, we've got the DINT, we've got everything set up here. We're going to hit apply and OK. And now for both of these PLCs, we are going to download that new information that we did offline into each of those PLCs. Now doing this, we want to make sure that we have all the information required for both so that they can both be downloaded and set up. And we'll put both of the controllers back into run mode as they come up. So now we have our producer and our consumer. Now you can see here we don't have any errors on our comms test 1. If we actually went into properties here, you'd be able to see the module information populate now, where we can actually see the revision code, the type of PLC that we're running. All that information shows up inside of that device. Oops, there was one other thing here. You can actually see down at the bottom, the status is running. Right? If there was an error or a fault, that status would come up as faulted or an error, and you'd be able to see the error codes. Also under module information or connection, you'd be able to see the module fault code, and that's where you'd use the help files and the manuals in order to figure out what your issue is at that point. All right, so now we have our producer and our consumer. Well, obviously our producer is going to be what changes the tag value, and we should see the consumer update with the numbers that we put. So here we're going to put any number in, so I'm going to put a 5 in. Now when I hit enter, we should see that update on the consumer side. Right, so we're going to put a 5 over here, and now you see that your consumer has a 5 in it. Right, so no matter what values we put in this particular area, 2020, we will see that populate over on the consumer side. And the speed at which that communicates is at that 20 milliseconds, that request for packet information. It goes back and forth at 20 milliseconds to pull that information back and forth. So again, here, this is a simple setup for produce and consume tags, and how you use that is completely up to you, right? So if I were to, here I'm just putting numbers into a controller tag, but if I were to actually go to the main program, and I'm going to make a bit called toggle, and I'll just make a quick toggle as a Boolean bit, and I'm going to have that toggle turn on producer 0. Right? So if I use now producer.0 here, and I use this toggle bit and I turn this on, as soon as this turns on here, you can see that the value over here turned on. And if we look specifically at which bit is turning on, we can see that consumer_1.0 is actually turning on to 1. Right, so if I shut toggle off, you can see that consumer_1.0 actually turned off. So that's the significant advantage to doing this type of communication back and forth. And what we did on one side here, all you'd have to do is replicate that again on this side, where you could set this PLC up to consume the tags from PLC number 2. You could also set this up to have, a self-running timer if you wanted to, right? So we can call this timer, make a new timer tag. We could then say, as long as timer is not done, set this to a 1 second timer. And then we could set up a simple program that says, if the timer value, right, so we'll use what we call a limit. If the timer.acc, so if that timer.acc is between 250 and 750, then I want you to turn on producer bit number 1. Right, so here now we've basically got a self-running timer that's going to run, and you're going to see a flashing bit. So now you can see over here on the consumer 1.1 that we have a bit flashing on and off based on the same amount of time that this producer_1.1 is actually flashing as well. So how you build your ladder logic and how you build your program around this communication is really up to you. Once you can establish that communication using producer consume tags, it becomes very, very simple. And you can see, just like we did here, I was able to set up 32 individual bits to be able to communicate between these two PLCs. And they don't have to be individual bits. You could use this as an entire word. Right? We could actually process data back and forth. We could send a value from a barcode scanner or an RFID tag back and forth. All of that's available for you to be able to send information back and forth if you need to. So that's basically it. That's setting up consumed and produced tags between two ControlLogix PLCs using Studio 5000. So if there's anybody that has any questions, I can stick around here for a little bit, answer some questions. If you've got some, please add them to the chat. If you don't have any questions, hopefully this was educational and you got something out of this. Like I said, in subsequent live streams, we'll do a little bit more. We'll do some HMI work, maybe some VFD stuff. This will be posted on my channel, so you're able to check it out. Trying to think of what they always say, subscribe and like if you like that stuff. I don't know. That's what my son always says. Okay. So Ben's got a question. Very good question, Ben. How do you select them if they're the exact same type? Well, all you would do is configure that in here. And because it's going to have its own IP address, that would just be set up as the same type. We don't really care if they're the same type. We would basically just go to Ethernet IP, add a new module, We would search for a 5380, which is the exact same type. We'd create that module, right? We'll call this, even though I don't have one, we'll call it comms test 3, and we'll say that that would have been at IP address number 3. We'll then hit change, update our revision number because that's important, and then we will hit OK. Right? It says, do you want to create it online? It could affect the running system. We don't care. We know it's going to fault out. And now you'll see that there's an error, but that the same PLC can exist because it has its own IP address. At that point, if you were to go to your consumer tags and edit the properties, under connection, actually what we'll do is I'll just go offline so you can see that. Edit the properties, under connection, you'll see that both of those are here, but they're under the producer name by the actual name of the PLC, not the PLC type. So here you wouldn't be able to put the same PLC name more than once. You would actually have to put an individual name under there. But whatever name you called that, for our lab's sake, if you called it BPLC or Ben's PLC or Chris's PLC, you would actually be able to see that. And that's why typically it's important to have a good naming structure for your PLCs and your ladder logic. So hopefully that answers your question, Ben. Anybody else have any questions, concerns? Hang out for a little bit longer. This is really important in the world of getting PLCs to communicate together. It's really important to really have the communications between cells figured out. Some of the advantages to this stuff is that you can actually have multiple cells transferring multiple pieces of data to do lots of things, right? You could actually have a bit turning on to pass, say that I've passed you a part, right? That's a nice, easy, simple one, right? But you could also use it for RFID tags, quality information. So when a part's running in one cell and you want to pass that part to the next cell, not only do you say, I've just given that part to the next cell, you also pass quality information. How many welds did you complete? How many failures were there? Was there any issues with that? And you pass that along as well. So there's some significant advantages to being able to pass information effectively and easily between multiple cells and multiple areas in a plant. In this day and age, this is by far the easiest way to set up, especially doing Allen Bradley to Allen Bradley communications using produced and consumed tags. It's very quick, very efficient. The only problem with it is that you do have to go online and offline a little bit. So this isn't something that you're going to do necessarily while a line's running or they're making parts. This would be more during weekend work or offline work. You want to make sure that you understand. You have to go online and offline to your PLC and download a bunch of times. So you will error out and you will stop the process when you're setting this stuff up. But once it's set up, then you're off to the races. So there's some huge advantages to that. So you also want to make sure that when you do set this stuff up that you give yourself some room. If you only needed 10 bits, I wouldn't suggest only setting up 10. Make sure you set up all 32 or set up 2 words of 32 so that you have lots of spares so you don't have to redo this all the time. Once it's set up, you're in good shape to move forward. Now, one of the things you'll notice, I'm going to flip over to the hardware screen again. You'll see now that we have all kinds of blinking lights going on our PLCs, right? So we've got our Link A1 set up here. It's flashing like crazy now. We've actually got some flashing lights down here on our architecture. This is because we've actually got communications between our PLCs, right? So we've got net A1 on both cards solid green, which means that they've got good connection between each other. And we've got our links pulsing, doing the communications between those two. So that's a really good sign as well. So now you're able to look at your hardware and really use those LED lights for troubleshooting purposes to be able to see kind of what's going on and how that functions. Right, so the first thing always when you walk up to a piece of equipment is to use those hardware lights for troubleshooting. You want to be able to see what's going on, try to be able to pull as much information as you can from them. There's a lot of good information that you can gather by looking at those lights and how they're operating. So we'll just hang out for a little bit longer here and see if anybody else has any questions or anything else they want answered. But that's the quick demo on produced and consumed tags using a 5380 controllers. So these are one of the newer models that are available from Rockwell. They're very fast. They have a safety module as well, which we have available. Um, to look at safety PLC programming and safety setups as well. We will also be using this later on to do the VFD and the HMI communications because they're nice compact units. So I'll just kind of hang out here and wait to see if anybody else has any questions. If nobody has any questions in the next couple of minutes, I will end the live stream and we'll carry on with the work, and we'll reconvene later on to talk about VFDs and HMI programming. All right. Well, it doesn't look like anybody's got any more questions, no concerns. So, um, oh, hold on. We just had one come in. Good timing here. Can you program a normally open consumer bit to activate a produced bit? No, you can't. This is one-way communication. So if I were to try to put a value in one of these fields here in the consumer side, it's going to get instantly overwritten by what's being produced. So this is really one-way communication. So in order for me to have this PLC doing some producing, PLC number 2 doing some producing, I would actually have to set up a produce tag over here and a consume tag in PLC 1. And that way you would have bi-directional communication where this produced consumer tag or this produced tag would be consumed by this PLC, and this produced PLC tag would be consumed by PLC number 2. So hopefully that answers Ty's question there. Anybody else has more questions? Let me know. These are good questions. It would be ideal if we had the ability to do this in class. Unfortunately, with the current pandemic, that's not possible. But hopefully, this is giving you a little bit of knowledge that you can take with you. There are some very good manuals that are available as well on produce and consume tags and sending messages back and forth. So if you're ever looking, there's some Alan Bradley does do a very good job of actually having that information available to you. Even if you use the help files, right? The help files on here are surprisingly good. So if you go to help files and to contents, you go to the index and you type produced, right? So there's produced connection properties, produced tag connections, producing and consuming arrays. There's all kinds of information that's available to you in the help files that is very, very good, right? So there's a lot of good information on how to set things up, how to use the tag dialog boxes, what do we set up for producing and consuming arrays. Booleans, synts, and ints can only be done indirectly. You can use dints, reels, and structured bits in order to be able to consume them normally. So if you're having issues ever setting some stuff up, I would suggest you look at the help files. There's some really, really good information there. Um, yeah, other than that, thank you everybody for coming and checking out the live stream today. Hope it was good. Hope it was educational. Please provide some feedback if you like it, if you didn't like this, if you'd like to see more, you'd like to see something different. I'll be definitely interested in doing some more of these for you, and maybe even over the summer. It's not the end of the school year in a couple weeks. I'd like to be able to do some more of this stuff for you. So if you're ever interested in more, please let me know. Other than that, hopefully everybody has a good day. We will reconvene at later live streams. Thank you very much.